You'll record. Awesome, great. Cool. I'll get this out of the way. Here we go. Sorry, just moving things around. Right, yeah. So earlier today we did the Install Fest. Some of you were still doing that. But we're going to talk about what we did on some level, because the whole point of the Install Fest is to get everyone on the same environment, as we call it. And by environment, we essentially mean operating system. And that begs the question, what is an operating system? What is, this command line interface that we seem to want you to do so badly compared to, normal Windows or Mac, your graphical user interface? So we're going to just talk a little bit about what an operating system is, what this Unix idea is. Then we're going to go through some extremely common and directly useful Unix command line commands and how they work. And then some that are a little less important, and we'll see how much time we have to give to those. And then we're also going to talk about Git, what Git is, what its relationship is to GitHub, and how to interact with it from the command line. And I'll say up front, this is a lot. For better or worse, we have to front load some of this stuff in a program like this. And if you feel overwhelmed, that's actually not unreasonable, because I know, for instance, like I didn't start using the command line until, sophomore year of college, and I didn't touch Git until junior year. So the fact that all of this is up front is a lot to do with how condensed the program is. And that's just, we bite the bullet early and get you used to all this, but they are complex tools and ideas. Okay, so intro to Unix. What is Unix? Well, whether you're on, some version of Linux or Mac OS, or you're using Windows with this, WSL thing we have, we're going to refer to all these environments as Unix, by which I just mean, this text-based command line interface. So what is Unix? Without going very deep into the details, Unix is essentially an operating system architecture and a set of tools that allow a user to interact with their operating system purely through text. So a lot of this ends up going into the history of it, but essentially Unix is pretty old. This brings us into our detail section, where basically Unix was this specific operating system invented at a place called Bell Labs in the 1960s by the same people and by the same company that invented the C programming language. They invented a lot of these like breakthrough ideas in early computer science, or early software development rather. And Unix was well designed, but it was totally open source. So people, there was no like canonical version of Unix. Everyone just kind of made their own. Every university had its own. That's who was using computers back then. And over time, this got complicated because computers weren't really, this was way before the internet. So computers were sort of one-off things, just like your cell phone in the 90s. Just like every cell phone kind of had its own, software on it. And the next cell phone you got was totally different software. And you couldn't expect your contacts to like transfer over. That's how computers were for a long time. And then Apple and Microsoft came around in the 80s, and they created their own operating systems and sort of unified these environments. And Apple from the beginning went with a Unix-like architecture. It's not exactly Unix, but it's close enough to where most of the commands are the same. And Microsoft did not. Microsoft went with this private thing called MS-DOS, which to this day, I think it's very funny that I worked at Microsoft and I worked on Windows, and this part of the system is locked down. No one can see it. Like 20 people in the company are allowed to look at it. It's a mystery, and it's what they call security by obscurity. Just no one gets to see how MS-DOS is actually implemented, unlike something like Linux, which is totally open source. But basically, there were a couple of these approaches. Linux was an open source version of based on Unix. And by the 2020s, we have a pretty good system where you're either on Linux, which is based on Unix, but they're all slightly different. And Linux, which I wonder if anyone in the class is actually on. I'd love to see that in the chat. But if anyone's actually on Linux, Linux is very much like you built your own car. You better know how to fix it because you built it yourself. And Mac OS and Windows are like buying a car, and you can bring it into the shop. And because of that, it's pretty standardized. And Mac is fundamentally Unix-like. There's always these slight little differences, and Apple has a tendency to push updates whenever they feel like it, and that can often break things. And then Windows was pretty bad for a while, but now we have WSL, which hopefully everyone is on. So using Windows and WSL, you're essentially on a Linux environment, and it works similarly enough that Linux, Mac OS, and Windows are more or less the same system. And this is important because it's essentially the lingua franca of operating systems, meaning it's the common language. Even though it's funny, lingua franca means French language. French is no longer the common language of the world. It's English. But when it comes to operating systems, especially if you ever get into like cloud computing or something, you might be working with a computer that is running an operating system you've never heard of. You don't know anything about it, but you can generally rely on the fact that it's going to be Unix-like, and it should have a lot of these commands. And what commands it doesn't have, you should be able to use the commands to download the commands you want to have. So Unix is a common language by which we all understand how to work with an operating system. So I just want to stop for a minute because a lot of times with these lectures, it's like I can just be talking the whole time, and especially remotely, it's not clear when people have questions. So please feel free to ask questions, and please, it's not, I can't always see everybody at the same time, and it's hard to read the chat at the same time I'm lecturing. So please do just speak up. There are no dumb questions. In fact, dumb questions are the best kinds of questions, because when you answer a dumb question, the answer is not nuanced. It's obvious, and then it's permanent. It's like that forever. So if there's any confusion about something you feel is dumb, please do ask it. So yeah, I'm going to leave like 10, 15 seconds to do that at a time, and if no one responds, we'll keep moving. And you can give me feedback eventually in the feedback doc we give you, but if I'm going too fast, I also want to know that.
Really quick, are they both operating systems, Unix and Linux?
Sort of, yes. So that's the thing. Linux is an operating system, or even Linux is not an operating system. Ubuntu is an example of an operating system. Linux is, we're going to get to that, but this little section here, you guys can see my mouse, right?
Yep.
Okay, so this little section here called the kernel, we're going to get to that, but the kernel essentially defines the core of an operating system and how it interacts with hardware. And that's what Linux is. Linux is the core that all these other things like Ubuntu and CentOS and just any like Debian, like any one of these Linux operating systems, they're based on that core of Linux. And then Unix is more like a philosophy. Unix is this set of ideas for how a operating system should work, and that's what this image is sort of about. But there is no official version of Unix. Unix doesn't even exist anymore. It only ever existed at Bell Labs as an official version of something. And then a bunch of universities like copied the idea and named it their own thing. And then eventually everyone settled on something like Ubuntu or Windows or Mac OS, and that's an actual operating system. But good question. Yeah, so moving on to this whole architecture thing. So basically, when we think of what an operating system is, it's important to understand how a computer works at its core. A computer is essentially a machine that can read and run a program. And it sort of starts and ends. It starts like your actual computer, what it does when it boots up is it looks at that first memory address and it just starts reading from there. And that means by default, it doesn't really know that much, and it can only run one program at a time. And that made early computers kind of really hard to work with, because early computers kind of had nothing, which is why way before Windows, Bill Gates was the first person who thought, wait a minute, I can sell software. And he made essentially a programming language compiler for an early hobbyist computer so that the hobbyist computer did something. It wasn't just like this piece of metal that just, didn't do anything. It now could like run a program that could theoretically run other programs. So that's what an operating system is. It's a program whose job is to understand what all the hardware is, to manage it, and then to schedule the running of other programs. So like if you're listening to music and you're, on Chrome and on YouTube, or I don't know, if you're doing a bunch of things at the same time on a computer, it seems like it's doing it all at once. And in the modern day, you might have like a multi-core computer. Maybe it can do multiple things at once. But at its core, a computer has always been able to do that multitasking, even when it was single core. And it's because the operating system is this main program that is running that basically says, oh, it looks like the audio wants to play. Let me give it, 100 CPU cycles, which takes like, fraction of a second. Then it says, oh, wait, they're moving the mouse now. We need to give some CPU cycles to that. And it's just constantly shifting off, saying who it's giving its resources to at that moment. And it's doing it fast enough that you don't notice that it's not actually playing music and moving the mouse at the same time. It's just moving between them very fast. So this is the image that sort of represents what an operating system is. And at the center of it is the hardware. The hardware could be made by anybody. If you're on an Apple machine, Apple made the sort of wise decision of saying, we make the hardware and the software, and it makes it really simple for them to guarantee there's no bugs, because there's only like, 2-3 versions of the hardware at a time. Windows and Linux took on a much harder problem, which is anyone can make the hardware and their operating system has to work with it. But the hardware is sort of what you're given, and it's not smart. It doesn't know how to do anything, which is where the kernel comes in. The kernel is the first layer of your operating system that commands the hardware to do things, and it handles all these hard problems of like, when you save a file, you're not actually saying, hey, computer, I need you to find a free space in memory, and I want you to store, the numbers 11011. You don't have to think on that level, because that's what the kernel is doing for you. And really, the hardware and the kernel are two things that are they're the domain of experts. Even a very advanced programmer, a system admin, is not going to mess with that stuff, because it's hard stuff. And it's the kind of thing that only gets updated once in a while when someone updates what Linux actually looks like. And just the average programmer never has to think at this level. And it's on purpose, because if you did think on this level, you could easily shoot yourself in the foot. Because, once you have access to your hard drive, you could say, hey, hard drive, spin as fast as you can for as long as you want. And you, as the regular programmer, don't want to accidentally do something like that. So that's where the shell comes in. The shell is called the shell because programmers like puns, I guess, and it wraps the kernel. I don't know why it's called the kernel, but just like it was popcorn or something, the kernel is the essence and the shell wraps it. And the shell is what you're going to be using all the time. The shell is how you interact with your computer through commands. And when you're in that terminal environment, if you're in Bash, that's an example of a shell. If you're in Z shell, that's an example of a shell. The specifics of what shell you're in is often beyond one's understanding. It's just, you take it for granted that this shell exists and it's popular. Like, honestly, I only use Z shell and I don't really know why. I just know that I've been taught Z shell is better than Bash. No idea why. But they're both good. They work. If anyone's curious, fun little tidbit, the original shell is called shell. It's still in your computer as SH, shell. And Bash was made by some religious Christian because it stands for born again shell. So that's a fun little tidbit that Bash is the born again shell. It's the better shell. But Z shell is the new born again shell. Right. And then your final layer is applications, and then I guess they're including utilities here. So I guess they're one and the same, but basically the shell is going to do a bunch of basic commands that we're going to look at soon, things like CD and LS. And those are going to allow you to like move around your file system in this, terminal, whatever command like way. But it wouldn't, like, while you have those basic commands, you have a bunch of commands built in. We would call those utilities, I guess. But basically, you don't want that to be all your computer does, because your computer by default might not have Python or Node or anything else. And so generally in the modern version of a shell, you're going to have a program like apt or brew, which is going to allow you to download new commands, what we would call applications. And so that's how your computer can do more. And it's worth noting that even when you're in the graphical user interface of your computer, that's still applications, as in at its core, Windows, Mac, any of it, it's all just text-based terminal type stuff. But at some point, someone realized, hey, it would be nice if we had a program that ran, that listened to your mouse and your keyboard and talked to a screen and to speakers and gave you this kind of audio visual experience, because that's going to be way more accessible for most people. But that's just happening at that last layer. The shell really is what the computer runs at the most basic level. And yeah, we have this thing here, files and folders. So first I'm gonna, how do I exit Zen mode? I know there's a way. I guess this is why you don't enter Zen mode, because, oh, there we go, okay. So I'm just gonna put that here and put this here and move them over a little. Make that a little nicer. You're probably gonna wanna see it a little better. So I'm just gonna, this is where we're gonna read stuff, and this is where we're gonna run our command line stuff, and you can see both, right? Looking for nods, cool, awesome. Yeah, so I'm gonna go to my home folder, and we'll explain all these commands soon. But the first thing to notice or to note is that part of this Unix philosophy is basically keep it simple, stupid. So the idea is that this basically, you want all of your programs, all your ideas to be as simple as possible, but to interact with each other well. So things aren't complex and bespoke, they're simple. And so part of that is that there's only two types of things that exist in Unix. There's files and there's folders. So now I were to look here, what do I have? I have to-do.md, that's a file. And then DevOps curriculum, install source, Tango test. I don't even know what test is. Those are all folders, and we will get to this. But if I were to type ls, that's list, and if I were to add, I believe L, that's going to show me a sort of more complex version of this list. And you don't really have to understand. I mean, this is why Unix is a little weird and complex, because this is very complicated. You don't have to understand what all it does. But if you look at this left thing here, you don't have to understand all of it, certainly not yet, but this leftmost row, you see it's either a dash or a D. Dash means file, D means directory. And those are the only two values for that slot. Everything is a file or a directory, and a file is something that can be opened or run, and a directory is something that can be entered into and can contain files or folders. So basically, a file is a real thing, and a folder is just a container for either more containers or real things. Cool. So any questions about that? Because now we're going to get into the more practical stuff. Everything I've said up until now, talked a fair amount, but it's all sort of just history and ideas. And really, you learn this stuff by interacting with it. And that's what we're about to get to. But I'm just curious if anyone has questions to begin with about, like, this sort of stuff, the architecture idea, the files and folders idea.
Yes, I have a question real quick.
Okay.
Yeah, what is that thing you open up to the left? I know the VS Code is on the right, but what is that thing on the left? All right, you can step it.
Okay, so this thing on the left is Windows Terminal. It's a program that lets you interact with Windows at the terminal level, and I'm running Ubuntu. This is because I'm on Windows, so if you're on Mac, it's probably different. You're probably on Terminal or a different, or iTerm 2 or something like that.
Oh, yeah, iTerm would be, I think, what this is.
Yeah. If your question is why does my terminal look cooler than yours, it's because of that link I gave. power level 10K or whatever. Basically modifying your terminal, even getting colors in the terminal ends up being a fair amount more work than you would expect. So basically there's tools like Oh My Z Shell is one of those tools on some level, and then power level 10K is this newer tool, which basically it just lets you automatically set it up so you have, you know, nice little pictures and stuff. And if I were to type nonsense, it tells me that I type nonsense. So that's kind of nice. Like, you know, I get this little like error thing, and you get other nice things, especially once you get into Git. It will like tell you things, and that's nice. All right, any other questions about the basic command line terminal Unix type stuff?
Yeah, you said dash is file. Are you talking about when you do like dash ls?
Say that one more time.
You
Dash.
said dash is a file and D is a directory?
Right, yeah. So when I type in the command ls-l, and we'll get to this, but basically ls is a command. Ls means list. Show me what's in this directory. And if I just do that, it just shows everything. But if I type ls-l, that's going to give me this sort of like verbose look at what is in there. And if I do that, it's going to tell me a lot of stuff. And I don't even remember what a lot of these mean. Like, I think this is like the size of the file. This is when it was created. You're seeing it twice, but one of these is like the owner, one is the creator of the file. But basically this thing here, this line represents, it's a little complex, but it basically represents the privileges for that file, what you can do with this file depending on who you are. And this thing all the way on the left here is either a dash or a D. If it's a D, it means it's a directory. If it's a dash, it means it's a file. Really, the best way you find out if something's a file or a folder is that if I try to go into do.md, it's going to yell at me and say, that's not a directory. Whereas if I try and go into DevOps curriculum, it goes there because it is a directory. So yeah, that is the file folder thing. And just we'll get into this more, but basically when you see stuff like this, it's a little shocking because it does look so ugly and complicated. And this is basically just an artifact of how Unix was created. So I mentioned this a little here, but basically a lot of these acronyms are incredibly short. And part of that is because you type them all the time. But part of that is also because in the early days of computing, if you could save, you know, space by making a command 3 characters long and not 10 characters long, you did. And so you get these very odd commands. So for example, like if I type PWD, you would never guess what that does. It's nonsense. And it just tells you where you are. It's a print working directory. I don't know why they chose PWD. I would have called it something like, where am I? There are commands like that, actually. Who am I is a real command. It tells you who you are on the system. So things like that do exist. But yeah, like you just kind of have to get used to the fact that some of these commands are a little weird. A lot of aspects of how it works are weird. And the main reason it is so weird is because they want to guarantee as much backwards compatibility as they can. So if you are randomly, you know, let's say you get like there's a joke in the world of computer science that you know, learn COBOL and you'll never starve. And you might be saying, what's COBOL? Well, COBOL is a programming language that was big in the early adopters of computers in the 70s, which were major banks, and they run on gigantic IBM mainframes that take up a whole room. And surprisingly, a lot of banks never updated. They just stuck with it because it works and they spent the time and effort. It's in their physical building. They're happy with it. But that means they need COBOL programmers, and all the COBOL programmers that exist at this point are like 65 or older because no one's learning COBOL anymore. But that's just this, like, basically, if you as a programmer are ever randomly having to work on a computer like that, you're going to be glad for the fact that there is this general idea of Unix and that it's going to be somewhat similar. And even though this stuff is obtuse, at least it's obtuse in the same way, no matter where you are, no matter how far you go back. Cool, yeah, so let's get into some of these commands. The first section we're going to talk about here is folder navigation. This is essential. This is how you move around. So unlike when you're in, you know, File Explorer or whatever they call it on Mac, you can't just, click things with a mouse. That's a much later invention. So you have to have ways of moving around. So the first basic thing is print working directory. That's just going to tell you where you are. I'm in /home/aloof Buddha. That's my name on here. I wonder if anyone understands the very deep Kendrick Lamar reference that is Aloof Buddha. Probably not. It's not a popular song, but he says it. But anyways, that's generally going to be represented by a squiggle. Your home directory is going to be different no matter, depending on the environment you're on. But generally, once you're in your home environment, which is what you own as opposed to the whole computer, it's going to be represented by a squiggle. And you'll see that when I move around, this squiggle here will update to say where I am. But instead of writing this whole thing, it just writes, okay, you're at home, which I can write PWD if I want to find out what that is. So yeah, PWD, you don't end up using it very much. You mostly just look here. Then LS. LS is going to tell me what's in the file I'm at. LS-A. So this is our first example of a flag. LS is a command, but commands, you often want to modify them in some way. And so they have these things called flags. A flag is a way of saying, I actually want a slightly different version of that. If it was a GUI or something, you'd probably be clicking like a toggle. But in the command line world, we use a flag. So I don't even know what -A means, probably all or something. But what it's going to do is it's going to show me all the files in there. And suddenly there's a lot more files than before, right? Why? That's because all these files start with a dot. And this is just a shortcut that Unix decided it liked, which is that if a file begins with a dot, it's hidden, which means you don't see it with ls, you only see it with ls-a. Hidden files are just as real as any other file. It's just that you might have a lot of them and they're usually configuration type files. So it's a nice way to hide it, because like your Z shell RC file, you might not want to know about it that often. And yeah, it's a way, for better or worse, of configuring things in such a way that you just hide it so that the average user doesn't have to look at it most of the time. And then again, we could write ls-a-l, so you can give it multiple flags. This is going to show me all the files in here, including a lot of their information. Clear is a good one to know, just clears the screen. We will mention it. But an important thing to know is that when it comes to flags, you can bunch them up together. So instead of writing ls-l space -a, I can just write ls-la, and you see everything. So you'll use things like that sometimes. And that's sort of you'll see this a lot in Unix, that like, there's always a very concise way to do things. And it's sort of a matter of discretion if you like the way where you really spell things out, or the way where you just make it all one line and it's harder to understand. Okay, CD, change directory. Turns out if you do CD and put nothing in, it will just change directory to the current directory. So yeah, where could we go? Well, if I do ls, I can see where I am, and I can say, oh, maybe I want to go into my source directory. So I'm going to do cd space source, and I'll go there. And now once I'm here, what if I want to go back? Well, you might have noticed when we did ls-a, there's two seemingly folders here called dot and dot dot. So again, this is just shorthand, but dot means the current file and dot dot means the parent folder. Sorry, the current folder or the parent folder. So if I were to go to cd dot dot, that'll go up a level. Cool. So that's how I go up a level. And let's say I went really deep, I could go cd, what might be deep in here? Source. I'm going to go into, sure, learn Python. And you should, I'm having an easier time writing this because if you're on a decent terminal, when the computer can guess, if you type tab, it will guess. So basically I typed L and hit tab and it went learn dash. And the reason it stopped there is because I have learn Python and learn Django, and it wants to know which one I mean. So I hit tab again and it shows me some examples and lets me choose. So I'll say learn Python, and then I'll hit tab again, and and you can just keep going with it. And so now I'm in this specific folder. And I could go something like cd ... and that's, up one level, and then I can write a slash to say, I'm continuing up another level, and now I'm back home. Although I could similarly always just say cd tilde, and I go home. I could also write something like cd dot that will seemingly do nothing because that just brings me to the current folder, but that ends up being useful at times. And then of course there's a cd slash. So the two important shorthands to know are, or the three, I guess, are dot the current directory, or four, sorry, dot the current directory, dot is the parent, tilde always brings you to your home, and slash always brings you to your root. So if I go to root, you'll see there's this little lock there because it doesn't actually want me here. I, as this user called aloof Buddha, don't have access to this entire computer because I'm not the system admin. I mean, I could be, but I'm not. Because it really wants me hanging out in my home folder, and it only really wants to give access to slash to, anyone who really needs this access. But if I look here, there's all this stuff that a computer might care about, and we don't want to worry about that. We want to be in tilde, which, given that I'm on this Linux environment, I could also get to it by going home, aloof Buddha. And now I'm in my environment. But the main point is that files that are in your home folder or below, you can just run. But any file that's outside of your home folder and based off of root, you technically don't have automatic access to it. So the only way you get access to it is by writing that command sudo, which says, for a minute, make me an admin. I'll give you my password. And you might say, well, that's pretty weak. Why is that enough? Why is your own password enough to make you an admin? They know what they're doing. There's actually it's all set up nicely for you, but basically there's a group in Unix that says these are all the people that can even use sudo. So if you were, at a company or at a university and they didn't want to give you sudo access, you're just not in that group. And you might try writing sudo. It's not going to work because you don't have access to that command. You don't have permissions. But yeah, that's cd. And I go into this a little bit here about absolute versus relative paths. This is just basically the idea of if I say cd DevOps, that's a relative path because it's relative to where I currently am. Whereas if I said cd slash home slash aloof Buddha slash DevOps, that's an absolute path. So if it starts with a slash, that means we're starting from the root. It's a full path. And that's all the computer really understands. When I write cd DevOps, it's shorthand. The computer ultimately has to know the full path because that's its full address. But it's sort of like someone saying, hey, I'm already on Grove Avenue. What's your house number? And you say 78. But that's not going to be good enough for the USPS. They're going to say, give me your full address, 78 Grove Avenue, Cedars, New York, 11516. So yeah, it's just a matter of the full versus the shorthand address, location. Okay, so I should probably start speeding things up because we've only got into CD, which you're probably all already pretty okay with. But yeah, there's other things. Two important ones are make directory and touch. Make directory will make a new directory and there will be nothing in it. So I'll call this my dir. To ls, there's something called my dir. If I went into my dir, there's nothing in it. If I did ls-a, you'll see just dot and dot dot. That's all that is in it. So make dir makes an empty directory. Similarly, if I went in there, I could say touch myfile.txt, name it whatever I want. I created something called myfile.txt. If I open it up, should take a second. All this to show you it's empty. So touch and make directory are for a folder and a file. Just make something empty so that it exists. Usually there's a quicker way to do it. If you were to write code myfile.txt, it would just automate, or if that didn't exist, it would open up VS Code, you would see the file and the file name, and you would have the option to save it and make it a real file at that point. So often you're not using touch or make directory, but it's good to know. Something just worth pointing out here, file extensions are meaningless. This often comes as a surprise to new programmers. A file extension means nothing. It's just shorthand for programs to know, oh, I think, if that's a .txt, I'm the person who by default takes TXTs. Or if it's .py, oh, we should run that with Python. But it's really meaningless. You could name something, I'm going to say code dumb dot fun. Okay, that is a perfectly legitimate file name, and it's saying the marketplace has extensions. Really, marketplace can help with that. Okay, but I'm just going to write, print hello, and you'll see it's not highlighting it as if it's Python. It doesn't seem to know this is Python. But if I were to now write Python dum-dum.fun, it works. It's just a matter of like VS Code is not going to be super helpful if it doesn't know it's a Python file, and I named it something weird, so it doesn't know that. But a file is just a file, contains characters. Okay. CP, copy. You will have to use this sometimes. Where are we? Yeah. So CP takes a source and a destination, and it copies it. So I might have, a directory called, other dir, and then I might say move my file, which is here, into other dir. And now if I look, it's no longer there. But if I look in, I'll also do this. If I look in other dir, it is in there. So I just showed you move, right? I skipped over copy, but that's how move works. You move you can move a file into a folder. You could also move a file into a file, which is just renaming it. There is no rename command. But if I went into other dir here and I said move my file to hello world.txt, doesn't like that because MC is not a command. But yeah, so move most often is actually your rename command. And again, you might end up doing most of this in VS Code, but still good to know. Copy, you can copy a file. If I were to copy this hello world file and I would want to copy it, I think I mean, sometimes you just test this stuff out. So normally you copy it into a file, but I think I could just rename, I could just make a new file called like goodbye.txt. And now if I look, I have two files and they should have the same contents. And then importantly with copy, what if you wanted to copy a whole folder? So I'm in my directory. Let's say I want to copy the other directory folder. You'll see it has stuff in it. If I try saying copy other directory and I want, to call it another folder, it's not going to be happy, but it's going to tell me the issue. It wants a -r. Very often -r stands for recursively. So it means when you're working with a folder, I don't just want you to copy the folder. I want you to copy the folder and everything in it and everything in that, on and on. It's a little silly that you have to tell it that because CP is almost meaningless when it comes to copying a folder if it has stuff in it, and most folders are going to have stuff in them. But still, that's how it works. You'll see this -r a fair amount. We covered move, and now RM. RM is a pretty important one. RM is remove. So certainly I could do something like remove, this dumb file. It's gone. Now, what if I want to remove other directory? Cannot remove it. It's a directory. That's not such a helpful explanation, but basically if I add a -r, now it can remove it because there is, we're saying recursively, first delete everything in there and then delete it itself. And now sometimes you'll also see this, an F. The R means recursively, the F means forcefully, because even though it didn't show it in this case, because I own everything, if we were in a situation where I didn't own the file, or I don't know, there was some other issue, it would actually ask me the question, are you sure you want to remove this file? And you can answer yes or no, just like when you empty your recycle bin, it says, are you sure you want to delete this? Things like that. But one reason why this is important is that this is something, this is a rite of passage for all software developers to learn. I'm not going to hit enter. If I hit enter, hopefully if this is a good system, it's going to say, you sure? You sure? You sure? And it would ask me for my password or something like that. This means remove recursively, forcefully, starting at the root. This will wipe out your operating system. Given that I'm on WSL, it will just destroy WSL. If you're on a Mac, it'll actually destroy your whole computer, but a Mac is smart enough that it saves a part of your operating system in a space that even you don't have access to. In Linux, this will maybe brick your entire physical computer. You will not be able to recover your hard drive because there's no way in anymore. It's like burning down the door or something like that. So never type that in, but know that it's these little commands are insanely powerful when you add these little pieces to them. So that's all you need to know to do some real damage to a very unsecure system.
Benjamin, in terms of RM, let's say you're cruising through a little recklessly, and you realize, oh, like I didn't mean to delete that file. Is there any place? Obviously, we have trash and recycle bin normally.
Great question. No. That's I mean, that's what the -F is for. Basically, if you don't include if you don't include the -F, it should ask you when you're deleting something you shouldn't be deleting, are you sure you meant that? But basically, by default, remove -R is like deleting something from your recycle bin. It just doesn't exist anymore. Technically, if you want to go deep, the answer to your question is, if you want to pay one of those people who can, take a broken hard drive and dig through it, like this remove command, it almost certainly doesn't actually overwrite anything. It just marks it as okay to be overridden. So there's a good chance that file still exists. It's just no longer accessible to you by any way. And it's been marked to the system as garbage to be overridden. It's just, why waste time overwriting it now? Overwrite it when you have something to overwrite it with. But yeah, by default, no, there's no way to get it back. And that's why you shouldn't delete anything unless you really know you want to delete it. It's easier to hide the file by adding like a dot to its name, or to move it somewhere called like, recycle bin if you want. So there, you can create your own system like that, but no, by default, remove is really remove.
Cool, thanks.
Cool. I feel like we're going to break in like maybe 15 minutes, maybe a little more, but just want to go through some of this miscellaneous stuff first. But any questions about the file management, file navigation stuff? All right, fair enough. And it will all become more clear over time. I think it's funny that I wrote in the instructions, clear the screens of content, Command plus K should work on most systems. It does on a Mac. Turns out it doesn't on Windows. So, in that case, clear is your friend. We discussed sudo a little. There's certain things that you can't do without it. So, for instance, I'm on a Mac. I'm going to type apt-get. If you were on, sorry, I'm on a Windows, I'll type apt-get. If you were on Mac, you would type brew. But if I try saying apt-get, I don't know, what's a cool program? Let's do React. How about that? I wonder if it even has that. But if I say it probably doesn't. No.
Get neofetch.
What was that?
Neofetch.
Say that again.
Neofetch.
Neo search.
Fetch. FETCH.
Can you type it in the chat? Neofetch. Okay. Yeah. So neofetch. I don't think I already have this. Let's check. I'm going to type. I don't even know what it is, but I'm going to type neofetch. Doesn't know what it is. I think if I said something like apt search neofetch, it might tell me a little bit about it. Okay. Shows Linux system information with distribution logo. Cool. That seems maybe useful. So now I want to get it, right? I'm going to say apt get neofetch. apt-get install. That was my own mistake. It's apt-get install neofetch. Okay. Doesn't like that. It's saying could not open this lock file. What are you talking about? So basically, it starts with a slash. That means it's coming from the root directory, and it's having a permissions issue. And it's actually telling me, are you root? You are not root. But can you be root for a second? Sure. You can say the same exact file, and just note I'm using my up and down arrows that will give you your history in order. So if I say sudo that, now it's going to say, okay, prove to me that you're who you say you are. And it's going to want to download some stuff. And it's not really important that I show you this part, but whatever, we're going to download it. And yeah, you usually are not going to read this stuff, but it is, we would call these logs. Some people are paid a lot of money just to read logs all day. Cool. So now at this point, I should have something in here called neofetch. And I guess that's what neofetch does. It shows me the icon in a cool graphic. Oh, it's telling me some things. I like that. I didn't even know my theme is Adwaita. Good to know. So that's cool. But yeah, so I was only able to get that because I used the sudo command, because by default, generally, if you're downloading something or you're doing anything that's remotely sensitive that you might not want just anybody who has access to your computer to do, it's locked behind the sudo command. And then there's some file navigation stuff here. You will almost never use this stuff, but it is good to know, especially if you end up on a computer that just doesn't have access to Visual Studio Code, can't get access to Visual Studio Code. So if I were to, let me find something like, we're going to go into Tango. We're going to go into the curriculum. Let me just find a file. It's going to be very meta. We're going to go into the file for this class. Okay, so here we are, CLI Git VS Code, which we're looking at right now. But if I typed head CLI, okay, it's showing me the first bunch of lines. I type tail, showing the last bunch of lines. This probably seems like a pretty not useful tool. I would agree. A little more useful is this thing called less. Weird name, I know. Why is it called less? Less is going to show me the whole thing and let me navigate it with the up and down arrows. So we're getting there pretty good, right? And then Q to quit. There's also something called more. I don't know how it differs. Oh, I guess more tells you, interesting. I don't know. They're all slightly different, but you generally don't use them very much when you have VS Code. One thing to know is there's this thing called VI or Vim. Let's see, my system probably has access to both. Vim is just a more modern version of VI. Vim is the command line editor. So it's like, just like VS Code is like your graphical code editor, Vim is for people who never take their fingers off the keyboard. Some people love it because it is so, there's so many little shortcuts. I don't love it because I just opened it, right? I want to start typing. Okay, normally it doesn't do that. It is working for some reason, but you'll see on the bottom it says insert, right? That's because I'm in insert mode. And if I, like, basically if I want to save this file, I have to hit exit to get out of insert mode, then colon, you'll notice that at the bottom, then right quit, and I'll hit enter, and it's saying, oh, you didn't give me a file name, so I'll have to do that again. Colon, I think I would have to say it like, I could say quit and just exit out, or I could say write and give it like a file name. I'm just going to say quit and exit out. But basically, it's very weird. It's like Unix in that it's all these very obscure commands. I avoid Vim like the plague, but some people love it. You might turn out to love it. See, I didn't plan that, but I actually wrote that down here. Some people love it. I avoid it like the plague. I really do not like working in an environment like that. Okay, so final things before we take this break. No, I guess we'll go all the way up to right before Git. But yeah, so we have these interrupts. Sometimes your computer is running something and it needs some way to tell the operating system, I need to stop running this even though I'm in the middle. So you'll notice that if you open it up something like Python, you can write everything you want. But how do you get out, right? Escape, that's not working. So if I write exit, what happens? It's actually telling me, okay, well, there's this command called exit. So that'll work, but also there's this thing called Control D that will exit. So if I hit Control D on my keyboard, that's going to exit me out. That'll always exit you out, but sometimes too much. Like notice this, I'm going to keep hitting Control D. Boom, I just killed that program. I didn't even think it would go that far, but it did. So yeah, Control D is pretty powerful. Whereas there's this other thing, Control C. So if I'm in Python and I say Control C, Python doesn't kill it for Control C. It says, oh, you just gave me a keyboard interrupt. I'm just going to tell you you did that. Control D will work. If I'm in Node, I wonder what happens. Control C. Okay, it says hit Control C again and we'll exit. So it's kind of nice that, like, Control C is sort of your soft interrupt and Control D your hard interrupt. But if I do Control C here, I wonder what happens. Nothing. It gives me this like error code, but I'm still in the terminal. Cool. So those are good to know about just because they tend to work across any program you're in, because they're not program level commands, they're like operating system level commands. Okay, a few more things that I'm going to mention. Some of them will seem unimportant, some of them will seem useful, but you won't know how to use them. So echo seems really unimportant. I can do echo hello and it prints hello. Amazing, right? Echo seems useless. Echo is useful for one thing generally, which is your computer has all these things like variables, like path, right? So if I were to write echo variable path, it's actually going to show me what's in the path. So echo can basically take a line that shell that is meaningful to the shell and it interprets it and then writes that to the console. Then there's things like sort. Why is that taking so long? Oh, I have to sort a file. Okay. So let's say I sorted to do.md. That's going to sort that file in alphabetical order. Not so useful, but these things are sometimes useful when you combine them. Find, you're generally going to have something better on your actual, operating system, like searching in Windows or Mac, but I could do find, I guess, SR doesn't know about that. Source, it does know about that, and I guess it prints everything in there. So not necessarily that useful, but generally there's flags to modify it. grep is even more powerful than find. It could take something like source, but it won't just print. I actually should be careful with that. Let me say something like day one. It won't just print the file name, it'll print the contents of the file. So I think this will work, and it can take a while because it's basically searching every folder and file from this level down for the phrase day one. I'm actually just going to kill it because it's not going to work in time. But grep is one of those tools that once you add a lot of flags, just people are very masterful at saying, it's the good way of searching everything for like a specific string. And then there's man. Man stands for manual. So let's say a command like cat that we haven't seen yet. I can look it up. It's going to tell me about it. Concatenates files and prints the standard output. And here's all these different flags. You can keep going. Examples. I find that man is not terribly useful, but what is very useful these days is this thing called explain shell. You guys might get a lot of value out of this, so that's not what I meant to do. Is this not linked to the right thing? No, it is. Okay, well, let's try that. I'm clicking it. This is a website called explainshell.com. You can give it something complicated and it will tell you what it is. So this is a really complicated line and it will break it down what each part of it does. And it's very nice. But it works for simple things too. So if I'm going to type sudo apt get install Neo, what was that thing called? Neo
Fetch.
Fetch.
fetch. Okay, so I'm gonna type that. And it's gonna say, okay, sudo, that executes a command as another user. More or less, that's what it does. Yeah. apt-get, package handling utility, install. And then we're gonna get this whole thing saying like, here's what this actually does. Here's all these possible, I guess this is explaining how apt-get works at this point and all the arguments it can take. It doesn't actually know what neo-fetch is, but I find this very useful. And if you're ever in doubt, you can just say like, make directory hello. It's gonna know. It's gonna know. So yeah, explain shell is a useful tool to like bookmark. And just increasingly, we're getting to things that you just probably won't touch that often, but it's just good to know because it will eventually come up. These are operators. It's another idea in Unix that helps you combine commands. So the wildcard is really important. Let's say I was in my directory. So let's say I wanted to do something. Let's just see if this works, because sometimes you just have to experiment to see. I'm going to create two files. I'm going to call them file1.txt and file2.txt. Let's see if that works. Great, I call them poorly, but the point is I have these two files and something called another folder. What's in another folder? Okay, so what if I want to move all the files, or let's say I have a third file. I'm going to say touch hello.js. Okay, so what if I just want to get those text files? There's kind of not a great way to do that except with wildcards. So if I were to say something like, let me just look up for myself. So move, I give it the file first. No, I give it. So basically, I would be able to move a single file like file1.txt into another folder, and that would work. But I could also say something like move wildcard. So move everything in here into that folder. And then I could also say something like wildcard.txt, which is to say move anything as long as it ends in .txt into another folder. And I'm going to do that. And now when I look, I didn't move hello.js, but I did move everything else. And so wildcards are a useful idea in that way, and you'll see them in other parts of programming. Okay, and then there's these input redirection things. Mentioned before, we have echo, so I could say something like echo hello world. It's not that useful, but what if I said echo hello world, and then whatever is output by echo hello world, redirect it to a file called hello.txt. So now if I were to, I could say something like head hello.txt, it's in there. And let's say I tried that. Let's say I tried that again. I would say goodbye world. Say head. Okay, now it just says goodbye, but what if I wanted to add something to something that already existed? In that case, we have this 2-arrow redirect. That means don't overwrite what's in that file, instead append it to that file. So I'll do that a couple times, and then I'll say head, and so it's in there a couple times. Cool. Then there's the pipe operator. In order to make the pipe operator seem useful, I'm going to put a hello world in there. Okay, so now if I say that, we see hello world is at the bottom. So what if I said, show me all of the hello world file, and then I want you to sort it? Well, I could say pipe, which means take everything that's the output of there and pipe it into this file, or sorry, pipe it into this command. So it's as if I wrote sort parentheses head hello.txt. Instead, I'm saying hello.txt, pipe it into sort. And well, I guess H comes after J, but or G, but whatever. That if it sorted it would have done something there. There's the and. So I could do something like touch file1.txt and touch file2.txt. It's generally not the way you would want to do it, but basically I just created 2 files because I ran a command and another command. The important thing to note though is that when you say and, that's going to be, it's going to start running the first one and then immediately start running the second one. And that's what we call a race condition. So if anything in that first file needs to get done before that second, or if anything in that first command needs to get done before that second command makes sense, you don't want to do it in this way because you don't know which order they're going to finish in. So instead you would write something like touch file3.txt and code file3.txt. These are what do you call it? These are sort of arbitrary things I'm coming up with, contrived, whatever, because there's better ways to do this, but this will first create that file and then open it. And I wonder what would happen if I did something like create file 4 and at the same time try to open file 4. Like it might not mess up, but it can mess up. But it's mostly important just because you'll see other people doing it. I wouldn't myself touch most of these besides the wildcard for now. But yeah, that's everything, and that's a lot. And after this, we'll get into Git. But that's just sort of a high-level overview. And yeah, if anyone has any questions, feel free to ask me. And after that, we'll just take like a Zainab. What about a 15-minute break, 10-minute break? What do you think makes sense? If we're trying to end at like 2:15, 2:30, then probably 10 minutes is better.
Do you guys feel like you need 10, 15?
That's the real question. Yeah. What kind of break do you guys feel you need?
Votes?
A 30-minute.
15.
15. Let's do
15.
15.
Fair enough, yeah. Okay, so just before we go on that break, anyone have any particular questions about this stuff?
I have one quick question.
Yeah.
So this all seems very cumbersome. And there's a reason why GUIs were invented. How much of using various terminals and Git commands and stuff in the development world is actually because it's genuinely the most useful, efficient way to do it? And how much of it is some old programmers with a stick saying, get off my lawn, and I will never do something graphical because I look cool doing this?
Yeah, so you will encounter that latter opinion sometimes, but it is careful to see how there's sometimes a point to it also. So basically my attitude is I'd rather use a graphical thing for almost everything, which is why I prefer using VS Code. But there's definitely times where, like if you want to run your code from within VS Code, it's going to want you to set up like a config file and do this and do that. And behind the scenes, it's still doing this command line stuff. So you're going to have to know it for the sake of setting up that, GUI type config. So I would say that unless like it's sort of like a fallback, as in you need to know that worst case scenario, you don't have access to any GUI thing. You can do it in the command line, but it's usually more cumbersome. I will say though that once we get into Git, this is a common argument. Some people say it's okay to use a visual tool for Git. My attitude is that I started on a visual tool for Git and I ended up messing up things so bad that I learned my lesson, because that visual tool is running real commands behind the scenes, and you'll get yourself into a pickle and then you'll look up, oh, what commands did it run? And you'll be like, I don't understand any of those commands. And you don't know how to get yourself out of that situation. So it's kind of good to use the command line thing until you're comfortable with it. So at least you have that as a backup, then use the GUI thing. And when the GUI thing fails you, you have that backup, but you don't want to become totally reliant on the GUI thing, because then you don't understand what's at the level below it in the case you need it. Yeah.
Thanks.
Cool. Any other questions, or y'all desperate for that break and then we'll do some Git?
I have a question.
Great.
I was going to ask, is it possible to see these files on your computer? And if so, where are they found?
Oh, great question. Yeah. So this is going to be easy if you're on a Mac. They'll just be accessible in the file system. But I'm assuming you're on Windows, Javier?
Yes, I am.
Exactly, right. So this is a really good question because I didn't include it anywhere, but Windows people will want to pay attention to this. So you're in WSL, right? And sometimes you're gonna have a file that you like downloaded to like downloads, right? And you want to get it into WSL. How do you do that? Well, the only good way to do that from File Explorer is you open up File Explorer, and I had to Google this, and I don't know why it's this esoteric, but /WSL $, enter. That's going to bring you to your WSL, and you'll see you can go Ubuntu, you can go Home, Aloof Buddha, and you'll see here, I pinned it. That's the real solution. You want to go to your home folder once you do that WSL stuff, and then you want to pin it to File Explorer. And then from this point, I could take any file from anywhere and just drag it in there. Yes, that's a really
Appreciate
good
it.
question. We need to make that, I need to include that in the install fest for Windows people. All right, anything else or break time?
I had a
Yeah,
question about
yeah.
command flags.
All right, well, we'll go with Mickey first, but I'm loving
Sure.
hearing all these questions.
Mine's on the same pattern. I'm pretty new to the WSL.
Yeah.
I've gotten it extension in VS Code,
Mhm.
and it actually pulled up my file system from just what I was working on with Windows previously. So is there a separate file folder in Ubuntu, but can it still access files outside of itself?
I'm not
I don't
sure-
really understand the virtual machine concept of it, I think.
I don't think I fully understood your question. Are you saying that something works as desired or not as desired in VS Code?
As I was because I had everything installed just from Windows, trying not to use WSL. So I got WSL, almost installed everything else through that in the terminal. And then pulling up VS Code with the WSL extension, I got the terminal in VS Code. I wasn't sure the files, if it was going to have to be like what you're talking about, like putting them into a file folder that says WSL. Because right now it's reading through the terminal files that are in like my C drive that I would
Yeah.
have had access to previously.
Yeah, well, that's probably, you see how here it's saying Z shell curriculum or whatever, and here
Yeah.
it's like showing me what looks like. So there's a good chance that this thing right here for you, which I
Mhm.
made defaulting to my shell and to, to Ubuntu, is actually just looking at your file system. That's something we can work on in the install fest thing, but that is something we want to get right. That is a little weird for Windows, where Windows by default is going to assume your VS Code wants to interact with, the Windows file system, and you kind of have to configure it to make it, by default care about your WSL file system, which they are separate.
Okay, 'cause it's running. It's the bash, not a PowerShell terminal.
Yeah, I mean, I'm not surprised that it's running on some level, but you might eventually hit issues because like from that PowerShell, you're not going to be able to write like apt-get, or you shouldn't be able to. I'm not positive, but we can look at it during the
Yeah, I'm very interested in it. I got through
Yeah.
a lot of stuff with Git Bash previously, so I could, like virtual environments I couldn't do through PowerShell, and that got me over to a Git Bash.
Yeah, as a Windows user, I've encountered these things before, so we can do a walkthrough after
Okay.
the lectures today and go through this kind of stuff. So
Thank you.
And ultimately, if your environment works, it works. The question is really more like, if you think it works, and then it turns out down the line, it's like, oh, well, it's kind of like some of it's in this world, some of it's in that world. So we're just trying to avoid that stuff. But if you can run code, that's really what matters, until you can't. Yeah, and what was that other question? We'll take that last question and then do our little break.
Yeah, mine was a quick one. I was just curious. I've noticed that some of the flag arguments for various commands will preference with a single hyphen, and some of them will preference with 2 hyphens back to back.
Yeah.
What's the
Yeah,
difference?
that's a great question. Yeah, I mean, that's a weird like convention that became a thing, but very often, like if I have a node and I do -v, it's going to tell me the version. And yet usually there's another command which is identical, which is --version. And so that's usually how it works, in that the dash letter is shorthand and the -- word is longhand. So certainly this is readable by anybody, whereas this is, simpler to type in, but it doesn't translate itself. So I think that's usually the case. I don't think it's generally the case that you're going to have something that's only in -- form. Yeah. Cool, but good question, yeah. Cool, yeah, so we're gonna take a break right now, and when we come back at 1:45, perfect timing. Sorry, 1:45 my time.